Okay, in this video we're going to talk about variance and standard deviation. So just a reminder, we're using the same data set that we used in the last variability video, which is a set of 100 scores, okay? And these are the scores. So the question we left with on the last video was, how do we get a better descriptor of the variation among scores in a sample than the range and interquartile range? So we saw that those give some sense of how the data vary, but there's a lot of information that's lost in those. So that's what we're doing in this video. What are the measures of variability that can best capture the variation among scores in a sample? So the most straightforward thing might be to simply measure the deviation of each of the scores from the mean. So, for example, these are the first 6 scores, the lowest 6 scores, so we're just going to subtract the mean from each of those to calculate the deviation of each of those scores from the mean. So, for example, here's the mean. We subtract the mean from the lowest score, getting this deviation of negative 23.75. We can do the same thing for all of these scores, getting deviations from each of those scores. So here we just see subtracting the mean from each of these scores gives us these deviations from the mean. And what happens is that all the numbers below the mean will have deviations that are negative, and all the numbers above the mean will have deviations that are positive. So with about an equal number of negative deviations and an equal number of positive deviations, adding them up they would just cancel one another out. So we would want to take the absolute deviation, so ignoring the sign. So what we can do is just add up all the absolute deviations from the mean across all the 100 students with the 100 scores, and then just divide by the total number of students or scores. And that will get us the mean absolute deviation from the mean of all the scores. So that number turns out to be 12.81. So adding up all the absolute deviations, these numbers, the absolute value of these numbers across all 100 scores equals 1281, and then we're just dividing that by the total number of scores to get the mean absolute deviation from the mean. And so this measure is I'm using to just illustrate the basic idea of what the variance and standard deviation are calculating, and that the difference between the standard deviation and variance, which I'm going to show you in a moment how to calculate them, and the range and interquartile range, is that the variance and standard deviation capture the variation of every single score from the mean. But for statistical reasons, the variance is calculated somewhat differently than what we just described, but conceptually it's the same thing. So the variance is pretty similar to what we just did with the absolute deviation. The only difference is that whereas before we canceled out the negative numbers by simply taking the absolute value, to calculate the variance, what you do is you square the deviations. So you simply take the score, subtract the mean, and then the deviation from the mean is squared. Okay? And then you add up all of those squared deviations and then divide by the total number of scores, and that's what the variance is. So here, illustrated with the two lowest scores, we simply square the deviation from the mean, which is that number, 564.06, and again square the next deviation from the mean, which is 473.06, and then we do that for all 100 means, so we get 100 squared deviations from the mean, for all 100 scores, so we get 100 squared deviations from the mean, one squared deviation for each score in the data set. We add all of those up across the 100 scores, and then we get a sum. So here is the sum of the squared deviations from the mean. And now to get the variance, we divide this sum by the total number of scores to get the average deviation from the mean. But actually, it's not by the total number of scores, which is n, it's actually by n minus 1, and that is for reasons that you don't need to know right now, but for statistical reasons it's a better estimate of the variance to use n minus 1. So we divide the sum by n minus 1, which is 99, and that equals roughly 214. So what you can see from this number is that because this number is an average deviation, squared deviation from the mean, the number is in units that are really different from the actual score. So if we remember, the range of our scores is from 35 to 85, but this 214 as a description of the variation among the scores is sort of non-intuitive because it's not on the same scale as the score. So to deal with that, we calculate the standard deviation, which is the square root of the variance. So here we see the standard deviation, which is the square root of the variance, square root of 214 in this case, and that equals 14.6. So 14.6 is a much more intuitive number to reflect the variation in the scores in scores that range between 35 and 85. Okay, so that's it for measures of variation. I'm going to show you the actual formulas on the next page. So here you can just see the formulas for these, how they're written out. So the variance is denoted as S squared, and this is for a sample rather than a population, which you'll learn about later. But a sample of scores, for example. And then this is the sum of the difference of each score from the mean squared, and then over n minus 1. And then the standard deviation is the square root of that. So that's it for the formulas for variance and standard deviation and other ways of measuring variability in your sample. Okay, thanks.